Dear students, good afternoon, and we will discuss about atomic radius continuation. So previously we started periodic properties. In periodic properties, we had first atomic radius, and about types of atomic radius we discussed. There are four types: covalent radius, metallic radius, and ionic radius, and van der Waals radius. For new students also, how to learn that, I sent that video link already, so I hope you also completed that. So afterwards, in previous class I was given how atomic radius varies in groups and periods. I was given, so what is the reason also I was given, and two more important things I was given there. One is lanthanide contraction, and for lanthanide contraction, what is the reason I was given. What is the reason for lanthanide contraction? Poor shielding effect of inner D and F subshells. What actually shielding effect I said. And one more thing is the most important: if shielding is more away from nucleus, if shielding is poor, then outer orbitals come towards nucleus. Okay, so what you can say is screening effect is inversely proportional to atomic radius or directly proportional? Directly proportional. Screening is more, then radius is more. Atomic radius is more. Correct? If screening is more, that means more protection. Means more protection from nuclear attraction towards nucleus. More the protection means going away from nucleus. Certainly distance increasing. That means radius increasing. So screening effect is directly proportional to atomic radius. So that's why atomic, if poor shielding effect causes depression or contraction in radius. D and F subshells are poorly shielding, so the outer D and F are attracting towards nucleus. So contraction happened in transition elements actually. So this is also one of the important thing what you have to remember. Screening effect is directly proportional to atomic radius. So last and final, atomic radius left to right, atomic radius increases, I told. Increase I told, no. In periods, left to right, atomic radius decreases. Decreases I told, but up to halogens only. Up to halogens. But again, atomic radius increases in noble gases. Atomic radius increase in noble gases. What are noble gases? Those only: helium, inert gases, helium, neon, argon, krypton, xenon, radon, those. Why, sir? What is the reason? Left to right, in period, left to right, atomic radius decreases, but up to halogens only decreases. But again, from halogens to noble gases, atomic radius increases. The reason, what is the reason behind it? Because in noble gases, I told you, noble gases, when they are in very close, means noble gases in their solid physical state. Noble gases originally exist as gases, but on compression they come closer somewhat with a minimum distance. Then you will consider van der Waals radius. When the two gaseous atoms in solid state, when they are in closest approach, half of the internuclear distance is called van der Waals radius. I was given. Please repeat that video. I was given van der Waals radius. So in noble gases, what radius considered? Van der Waals radius considered. That's why van der Waals radius means highest or not. First highest radius is van der Waals radius, then metallic, then covalent. Ionic depends on charge, I told you. Do you remember? Yes. So those all are very important. In noble gases, van der Waals radius is considered. So therefore, up to halogens, atomic radius decreases, but then again atomic radius increases in noble gases. Means halogens to noble gases. Noble gases. If you see, atomic radius of halogens are less than noble gases. Means noble actually should decrease from left to right, decrease. But here, what happens, like fluorine and neon? If you see, neon has more radius actually. Okay, not molecule, atom I am considering. Okay, and if you take chlorine and argon, argon has more. Actually must decrease atomic radius, but here what happens? Increasing. In noble gases, what radius consider? What radius consider? Van der Waals radius consider. So very important, sir. Please note it down, everyone, by having screenshot or pause the video and write down this. Correct? Now we will discuss about, so most important thing I was given there. So what I was given, spinning effect is directly proportional to atomic radius. Please note it down, that is very important. And one more thing I was given here, final conclusion. So highest group, like that if they ask, group with highest atomic radius means 1A group elements. Okay, and element 1A group, no? Because left to right atomic radius decrease. But noble gas has more, but comparatively noble gas and 1A group elements has more radius. Group with the highest atomic radius is 1A. Element with the highest atomic radius is cesium. Francium we won't consider because radioactive element, that's why. Okay, so like that we have to remember. Least means hydrogen. Hydrogen has least, no, because smaller one, because 1s only present. But helium also have 1s only also. But comparatively hydrogen is a gas and helium is gas, but helium is inert gas. Their noble gas is considered. So helium has somewhat more size. Okay, so like that you have to remember. And one more thing I was given, if positive charge increases for ions, if positive charge increases, then radius, what happens, I was given, then radius decreases. Am I given this point? For this I was given example also, because next we are entering this only ionization potential. Okay, ionization potential also charge required, so very important. Positive charge increases, then radius decreases. Suppose Mg is there, Mg plus is there, Mg2 plus is there. Which have more radius means this Mg. This is order of radius. Order of radius. For same ions like Na plus, Mg2 plus, Al3 plus. These are isoelectronic. This also I was given, isoelectronic species having same number of electrons. See here, charge is plus 1, charge is plus 2, charge is plus 3. More the charge, less the radius. So what is the order of radius? Na plus has more radius than this. Na plus has more radius than Mg2 plus, than Al3 plus. Understanding? So this is about how charge and radius related. Okay. Next thing for ions only. This is actually for ions means what type of ions? For cations actually. For what? Cations. Now for anions. For what, sir? Anions. For anions, negative charge increases, then what happens? Radius also increases. This is the most important thing for us. If a negative charge increases, radius increases. I was given an example like F minus and O minus 2 and N minus 3. Who have more radius means F minus or N minus? N minus 3. N minus 3. Because all have 10 electrons only. F, fluorine, oxygen, nitrogen. Actually electrons, if you see, you know this already. Actually 9 plus 1 and here 8 plus 2 and here 7 plus 3. What 7 plus 3, you know? Nitrogen atomic number is 7. 7 electrons are there. Minus 3 means it gained 3 electrons. So 7 plus 3. So here 10 electrons, here 10 electrons and here 10 electrons you have. 9 plus 1, 10, 8 plus 2, 7 plus 3. But even they have same number of electrons. Negative charge is there, but protons are less. This I was given already. Negative charge is more than positive charge, so they will move away from nucleus. Certainly n minus 3 has more radius. So more the negative charge, more will be the radius. More the positive charge, less will be the radius. This is the most important thing, and this is also you must know. Now we will enter into second property, that is ionization potential. So about atomic radius we discussed. Atomic radius from top to bottom increases and from left to right decreases. And here I was written one important point. Screening effect is directly proportional to atomic radius. For the shielding, then electrons will attract towards nucleus. Please remember, because we will use that in next periodic properties also. Okay, that's why. So next is ionization potential. Ionization potential or ionization enthalpy, okay, or ionization energy. This we call as IP simply, or delta H, okay, ionization potential, okay, delta H E, otherwise enthalpy ionization, okay, or else we use one more, that is ionization energy. First I will give definition for this. Okay, ionization potential means actually the amount of energy which is required to remove outermost electron. The amount of energy required to remove outermost electron from neutral isolated gaseous state atom. Three words I used. One is a neutral atom, isolated atom, gaseous state atom. Got it? In energy of orbit also, nth orbit also, I said IP and energy of nth orbit are with opposite signs. Energy of nth orbit is a negative, but ionization potential is positive, because this ionization potential is the amount of energy required to remove electron. So what is ionization potential? I will write definition. The amount of energy which is requires to remove valency electron. Remove what's a valency electron from neutral isolated gaseous state, neutral isolated and gaseous state atom. So this is very important, and this is called ionization potential. Okay, E is called what? I have tried. E is called ionization potential, and this is called first ionization potential. Sorry, and this is also called first ionization potential, or else simply we call as IP1. If you are remove valence electron from neutral atom, that is IP1. Okay, if you are removing, so I write like that. So removal of outermost electron or valency electron, removal of valency means, you know everyone, outermost electron. Okay, so removal of valence electron from neutral atom. From what? Neutral atom. E is called IP1. Okay, What is IP1? Removal of valency electron. Valency electron means outermost electron from neutral atom is called IP1. So same removal of valence electron from uni-positive ion. Uni-positive ion is called IP2. What is the meaning of uni-positive? Some M plus. From, if you are removing neutral atom like M, okay, uni from M plus means after removal of one electron from M becomes M plus. So M become M plus is IP1. M plus become M plus 2 is IP2. Understanding? Here I was given one thing clearly. M become M plus is IP1. Understanding? So this M plus further converted to M plus 2, that is IP2. Difference clearly understand. Time is not matter. Understanding is a matter for us. Okay. So from neutral atom, this is neutral or not? This is neutral atom. From neutral atom, you are removing electron. You are removing one electron, valence electron. Then M converts to M plus. Understanding? Removal of valence electron from neutral atom, and that energy required is called IP1. Understanding? From M plus, this M plus is called uni. Uni means single or not? Uni positive ion. From uni positive ion, you are removing one more electron, that means then M plus 2. So from neutral atom, you are removing first valence electron. Understanding? And from M plus, you are removing second valence electron. But without IP1, IP2 won't happen. So first you have to remove the neutral, from neutral atom you have to remove electron, then you can remove electron from uni positive. So without IP1, directly IP2 you cannot. Understand? Because in nature atoms exist like that. So what is IP1? Means the removal of electron from, the amount of energy required to remove outermost electron from neutral isolated gaseous state atom. Okay, so this I hope you understood. And suppose M plus 2 to M plus 3 if you are having, that is IP3 actually. What is IP3? The removal of valence electron from dipositive ion. From M plus 2 you are removing that the third electron, that's why IP3 it is. Okay, same story. From IP1 to IP2, IP2 to IP3. Directly third electron I will remove means I cannot. So first I have to remove electron from neutral atom to positive atom ion to dipositive ion, and dipositive to tripositive is IP3. Okay, understood? So here which one is big and which one is less, I will tell you. But before that, you must know one thing clearly. What is ionization potential? Ionization potential is amount of energy. Write down these all things. So the amount of energy which is required to remove valence electron or outermost electron from neutral isolated gaseous state atom. That is called ionization potential. So simply I will write some M and I am giving some energy. So this is required energy and converted to M plus 1 electron. So what this energy required is called? This energy required is IP1. Okay, so from neutral atom and gaseous state. Neutral, isolated, gaseous. Only gaseous state it is possible. Isolated means single. I am not isolated. Why I am not isolated? Because I am not single. Okay, you are isolated because you are single. So from M, isolated atom, okay, you are removing one electron, and for this removal of valence electron, what electron this is? Valence electron. This amount of energy is required. What this amount of energy? Ionization potential. Okay, same story. The same you can write like this. M gives rise to M plus 1 electron and minus energy this representation also ionization potential. Here minus energy in products is plus positive energy in reactants. Okay, both are indicates ionization potential. One more you can write for ionization potential understanding. M gives rise to M plus 1 electron, and delta H IP is some positive value. Okay, these all three are the representation of removal of electron or ionization potential. What is delta H or delta E? Few people will use enthalpy change delta H. In thermodynamics chapter in chemistry, fully you will understand enthalpy. Okay, so this delta H actually it is energy of or enthalpy of products minus enthalpy of reactants. Means these are the products in reaction. Right side what you have are products, left side what you have reactants. Maybe you know that. And products energy. Enthalpy is nothing but energy. One kind of energy. And one kind of heat otherwise. Understanding? Everything you will understand. No problem. So this, remember, this energy only enthalpy change delta H. What is delta H? Enthalpy change. That only ionization enthalpy. Okay? This is IP, ionization potential only, but change. Change in ionization potential. Okay? It's kind of heat or kind of energy. So delta H means products enthalpy minus reactants enthalpy. That you forget. But why it is positive, sir? Because why it is positive means it is endothermic, heat required. So what I written here, the amount of energy required to remove electron. That means this process is endothermic process. Endothermic process, do you know what is the meaning? The amount of energy if required, that is called endo. If amount of energy released, if this energy is that side, okay, that is exo. So like this we say actually delta H is positive, that is endo. Delta H is negative, that is exo. When delta H can be exo, when delta H can be negative, reactants must have more energy. Understanding? So if products have more energy, then positive. Understanding? So if products is more, if HP is more, HP means what? Enthalpy of products. If more, positive value, then endo. Why positive understood? Removal of electron is exothermic process or endothermic process? Endothermic. Okay. So delta H is positive. Clearly you will understand all. So okay. So you must know all these things. So what is ionization potential we discussed, and ionization potential, what is IP1 and what is IP2 we discussed. Okay. So what is IP2? Can you define now? IP2 means here the same story. This is IP1 definition actually. Okay. IP1 definition is this. If I want IP2 definition, then what you will say? IP2 definition. Same story, the amount of energy which is required to remove valency electron from neutral isolated gaseous state you written na? This complete thing you remove, then what you will get from uni positive ion is called IP2. Then that is called simply second ionization potential or else IP2 I written there. So IP2 means what? I was given there clearly the amount of energy which is required to remove valence electron from uni positive ion is called IP2. Now my question, one question, which one is big? IP1 is big or IP2 is big? IP1 is big or IP2 is big? IP2 is greater than IP1 or else IP1 is less than IP2, IP2 is less than IP3. Because I given very clearly M convert to M plus is ionization potential 1 and M plus converted to M plus 2 is ionization potential 2 and M plus 2 converted to M plus 3 is ionization potential 3. Okay, all are in gaseous state. Gaseous. gaseous state. Sir, why? If you see the radius m plus 2, m plus 3, who have more radius? If you see, the radius is more for m. Okay, so m plus 2 is smaller than m plus is smaller than m. So m is more the size. More the size means distance is more. Understanding? If distance is more from nucleus to outermost shell, distance is more means attractions are less. Attractions are less means you can remove electron easily. So what you can say, ionization potential is inversely proportional to atomic radius. Very clear point. Atomic radius is less, then IP is very much far. Okay, sir, with bag I have some amount, I have some money. If that bag with me only, I will hold it tight. Can you take that money from me easily? No, because distance between money and me is less. Means attractions are more. So that removal of that money from me is difficult. Same story. If the distance is less here, radius is less here, then outermost electron attract towards nucleus, so that for removal of that outermost electron, you need more energy. Got it clearly? So this is the most important thing for you. So ionization potential is inversely proportional to atomic radius. If you see the radius here, m has more radius, that means IP1 is less. Got it clearly? So second ionization potential is greater than first ionization potential and third is greater than second, because if you compare this, m2 plus is somewhat less size than m plus. Correct? So m2 plus, when it is having smaller size, it requires more energy to remove electron from it. To remove this third electron, you remove first electron here, IP1. You remove second electron here, IP2. You remove third electron, IP3. So to remove this third electron, it requires more energy because m2 plus size is less. This is what I am trying to tell you. So what I said here, IP2 is greater than IP1 and IP3 is greater than IP2, and here I was given one important relation. Ionization potential is inversely proportional to radius. If radius is more, then distance is more. Distance is more means you can easily remove electron. That's it. Okay, so this is about ionization potential, not completed, factors affecting ionization potential, as well as we have to discuss about how IP varies in particular groups and periods. We will continue in our next class. So why I am stopping here? Because that at one particular time we have discussed. Here a session completed already. So new session we will discuss about all those things. What are the factors affecting ionization potential, how IP varies, electronegativity, electronic affinity, all those things. Hope you understood this. Please revise all the concepts. You have few days time to revise all the periodic properties as well as periodic classification, so which we done previously. Please recap all those things so that these are very easy for you then. These all things can be very easy for you. So please recap.